Welcome to chords, offsets, and arcs. Let's first have a look at what we're even looking at here. I find sometimes these kinds of drawings can be very overwhelming at first. And once you kind of get used to what you're looking at and just figuring it out a little bit more, it gets a bit easier. So this is part of the trigonometry series. And the next step is carpenters. When do we use this? Well, anytime we're doing anything with circles. We have to lay out a circle, or we're doing a circular driveway or walkway, or perhaps a circular concrete wall for a silo, anything like that. We need to figure out where we can put our sheathing and our whalers and how big the circle is going to be and all these little details and what angles we need to cut our things at. So let's have a look around at our piece here. So we have a portion of a circle. We have a radius of 2100. We have an included angle, so the whole thing, 126 degrees. And then we're looking at what's called a first chord. So that one touches the outside of the circle and the outside of the circle, but it is not a radius, right? It doesn't go through the center. It just touches 2 points of the circle. Then there's another chord, the second one, right here. Same thing, right? Touches 2 outside points. So those points can be layout points for us. And then we also have a couple of offsets right here and right here. And those can give us extra point that we can put a stake onto so that we're not, when we're laying something out, we don't have to go all the way from here to here, but we can kind of put one halfway across. So we have more layout points so we can do a better job at it. Okay, since we're doing trigonometry, SOHCAHTOA, always draw out all your triangles. It just makes it so much easier. Okay, so we have several things that we want to find. We want to find the lengths for our first chord, our second chord. We want to find these little offsets. And then we want to find a couple of arcs. And we're going to find the arc for the first chord, for the whole thing, and then for that second chord. And I'll show you how to do all of that. So when we're dealing with something like this, we want to turn everything into triangles that make sense to us so that have a right angle included, right? So that we can use Pythagorean and that we can use trigonometry. So to find the first chord, we can take this big wedge and split it in half, right down the middle, which gives us a right angle triangle, which also means we have to take the 126 degrees and divide it in two. So I drew up a little extra triangle right here because I find it much easier to kind of break these up a little bit. So in your calculator, pull it out, make sure you're writing along. 126 divided by 2 should give us 63 degrees. Okay, so that's from here to here. So either we're working with this triangle or working with this triangle here. The way I drew it out, it's the triangle on the right here. My brain seems to work better making triangles go this way, but it really doesn't matter, whatever works for your brain. Now, what do we already have given to us? So we have the radius, which is also the radius over here, right? So we can draw that right in. So 2100, which coincidentally is also the hypotenuse, which is wonderful. 2100. Awesome. Now, what we're trying to find out with this angle and the 2100 is half of the chord length, right? We split the big angle in half, which means we're only going to find half of the chord length. So up here, I write half of the chord. That's really important to remember and to keep track of. So let's have a look. We want to use SOHCAHTOA. We have an angle, we have a hypotenuse, so that already means we can use so or ka, and we are looking for the opposite, which means we're going to go with this so. And we're looking for the opposite, so if we're marking this up, opposite equals sine times hypotenuse. So let's write that out. Opposite equals sine times hypotenuse. And you can either write it out like this, or you can turn it into a ratio and proportion, which we often use in carpentry, so it might make sense in your brain. So sine over 1 equals half the chord, right? Opposite. Half the chord over the hypotenuse. Same thing, right? Because you do the same kind of math, just a little bit different layout. So let's put in our numbers. So we have a sine of 63 over 1 equals to still half the chord over hypotenuse, which is our radius, which is 2100. So what do we come out with here? Punch it into your calculator. Should come out with 1871. Half our chord, right? So that means full chord is 1871 times 2. And we want to write it down just to keep track of things. 3742. And important to keep track. So half chord right there, right? Half chord right here, full chord right here. So that way we can keep track of what we're doing. So let's talk about our first offset then. So where do we even find that first offset? That is right here. So we've been working with this triangle, and this is the offset. So when you look at the line itself, it comes through the center and it touches the outside of the circle, which means the whole thing is the radius, right? Now, we can figure out this number right here from this triangle right here. So in general, the offset is, well, if we call this A here, is our radius minus A, right? So can we figure out A first? Well, let's see what we have. We have the hypotenuse. We could either use SOHCAHTOA or we could use Pythagorean. So we figured out half the chord, which is awesome. So we could go C squared minus B squared, and that would give us A. So let's see. C squared is 2100 squared minus B squared. So half the chord, 1871. 1871 squared. Oops. And what does that give us? 953.6. So that is A. So radius is 2100 minus A, so 953.6. And that should give us 1146.4. So we took our hypotenuse, so C squared minus B squared, which is half the first chord that we figured out, gave us A. And what we just figured out is that first offset, which is this right here. Cool. All right, so now to get to our second chord, that's this guy right here. There are two ways to go about it. I believe you can see this fancy triangle right here. So either we can do Pythagorean or we can work with our sine function again. So do we have this number? Yeah, right? It's half our first chord. Do we have this number? Yes, we do. It's our offset that we just figured out. So if we wanted to try it out like that, and we'll do both ways just so we can see if we're doing it right. For our second chord there, so that is half the chord, right? So that is the 1871. 1871. And our offset was 11. Oopsie, I need to move it over a bit. There we go. This way I can write again. What do we have? 1146.4. Okay, so to find our second chord, we could go A squared plus B squared equals c squared, right? So to fill that in, 1871 squared plus 1146.4 squared, taking the square root, right? Punching it all into our calculator, should give us 2194.3. And this is our full chord, right? That is the full hypotenuse of this triangle, which is all of the second chord, right? So if we were to do it the other way, just how we did before, so we know what this triangle is, right? This is the first triangle that we worked with, where we took the included angle of 126, we divided it in two, which gave us 63 degrees here. Well, if we divide that in half again, 63 divided by 2, that would get us 31 and a half, right? So we can do the same thing again and then use our with our angle and our hypotenuse, which is still our radius, to give us half of the chord. Okie dokie. Let me move the whole thing down. All right, there we go. So what are we trying to find? We have the hypotenuse, that is our radius of 2100. How about our angle? So that's the 63 divided by 2. So that's the 31.5 degrees. And it is half of the second chord that we're trying to find out, right? So this is the same SOHCAHTOA that we did before. There we can come back up to our so up here. We're trying to find the opposite. So if we smudge that out, then we're left with sine multiplied by hypotenuse, or what we see here, we can do the ratio and proportion, right? Either is totally fine and acceptable, whatever makes more sense in your mind. Okay, let's set it up. So we have sine of 31.5 over 1 equals to half the chord over our hypotenuse, which gives the 2100. Cross multiply, right? So sine 31.5 times 2100 divided by 1, but it doesn't change anything, gives us half the chord, which is 1097.2. Now, if we look here and we're really nervous for a moment, this is half the chord, right? That's what we're trying to figure out. So to find the full, we take our 1097.2, multiply by 2, right? Because we just figured out half the chord, and that gets us the 2194.4. So we're within 0.1 of a millimeter. I would say that's really acceptable. Depends if you're using 1, 2, 3, or all the decimal spots in your calculator. And that's kind of how she goes. So now to get our second offset, and I will move that over for us, we can see it a little bit better. Okay. Now our second offset is this guy right here, and same thing, right? From the center all the way to the outside, anywhere in a circle, that's the radius. And we need to find out our adjacent side here for what we figured out or what we were just working with. So then we can take the radius minus that side, which then will give us the offset. So let's call this one B. So B, we can take C squared minus A squared and pop in those numbers. So C squared, we have 2100. That still has not changed. Minus, okay, now we need to use half of our chord, right? Because that's the triangle that we're working with. So that is the 1097.2. Oops, let's remember to square this guy. And let's take the square root. And what does that leave us with? Punch it into the calculator. 2100 squared minus 1097.2 squared square root leaves us with 1790. Cool. 1790. So that is B right here. And then to get the offset, it's radius minus B. So radius is still 2100 minus 1790, which gets us to 310. There we go. That's our second offset. So now let's think about our arcs. So when we look at our drawing, right, now we found these points, or when we, from our center point, we now have various points that we can lay out, whether we lay out from one spot and move around or stay in the middle and we can kind of look in a few directions. But maybe we don't want to actually measure the length of the circle, right? Or of parts of it. So that's what we want to try out first. So we're going to find the arc of the first chord, which is all the way from here, all the way across, all the way to here, right? It's the circular part that's the arc to that first chord. So that's what we're going to find out first. Okay, so arc one, and then we'll also do a second arc after that for number two. When we are dealing with a circle, first we need to find out what the circumference is, right? So circumference of a circle is 2 pi r. So if we were going to find out the circumference of our full circle, 2 pi, and plug in our radius, 2100, and that gets us 13,194.7, right? That is the full circumference of the circle that we are trying to work with here. Now, for the first arc, we can set up a ratio and proportion. So we want to set up partial over full. And I'll show you what that means in just a second. So the whole included angle is 126 degrees. And a whole circle has 360 degrees, right? Well, if we're trying to find the actual length of just the partial circle, we'll call that the first arc. And what we have at the bottom here is the full circumference, right? The whole 13,194.7. Now we cross multiply and divide. So our full circumference times 126 degrees divided by 360. And that gives us the length of the first arc. So 4618. Looking at our drawing, 4618 is that whole length. Okay, so now let's do a second one. We're going to do from here to here. So basically from our second chord, and we'll be able to check if we're doing it right because we can double check it easily. Okay, arc number two. We already have the full circumference. We're still doing partial over full, and arc number two is half of the 126 degrees, right? So that was 63. So 63 degrees over 360, and we'll call that arc 2. Again, over the full length of our full circumference, 13,194.7. Cross multiply and divide gets us 2309. Now that you have this in your calculator, just punch in times 2, 2309 times 2, 4618, which is exactly this, which is excellent because it is supposed to be twice as much, right? because we took a whole wedge and all we did was split it in half. So it makes sense that the second arc is half the length of the first arc. So whenever you do anything like this, always write out SOHCAHTOA first so you can easily figure out which ones you want to use. If you have awkwardly shaped triangles, see if you can divide them in two so that you can create right angle triangles for yourself. And from here, you can use Pythagorean or SOHCAHTOA, trigonometry, to find all the things that you need to find. And remember that you are not just a great carpenter and math person, but you're also someone with experience and logical mind and brain. So if you get stuck, just come back to the beginning, write everything out as you go so you can retrace your steps, whether that's for immediately or for later when you're studying. It just makes it a lot easier and cements it in your brain. And then just backtrack, figure out what you were doing. What does it mean? What does this number mean? Why is it that? Why is it the radius, etc.? And you can logic your way through if you get stuck. So I hope this helps. See you next time.